Welcome to our video on section 15.2, where we're going to discuss the divisions of the autonomic nervous system. Our parasympathetic and sympathetic divisions of our autonomic nervous system have complementary functions. Our parasympathetic nervous system is known as our rest and digest and is used for conserving energy and replenishing nutrients. So majority of the time, this is the division which is constantly working within our body. And then in rare occasions, when there are emergencies or moments of stress, our sympathetic division is called upon for fight or flight. This could also be while you are exercising or have excitement. So we'll start off detailing our parasympathetic nervous system. The parasympathetic division is also called the craniosacral division because we're going to see fibers originating from cranial nerves as well as sacral nerves. So our preganglionic neurons will originate either in the brainstem here or from S2 to S4 from the spinal cord. And these preganglionic axons are going to be long, so they will extend almost near the organ or within the organ. And the postganglionic axons are going to be very short. So they're either going to be within the organ or very short, located just right outside the organ. And we'll see that the ganglia are close to or within the effector organ. We'll see some other illustrations depicting this in the coming slides. We'll also see that our preganglionic axons are going to have few branches, whereas when we compare it with our sympathetic division, you'll see that those preganglionic axons are going to branch quite a bit. And now for our sympathetic division, this is also called your thoracolumbar division. Thoraco because we have fibers originating in the thorax, and lumbar because it's originating from the lumbar area. Specifically, those preganglionic neurons are originating within the lateral horn of our spinal cord from T1 to L2. And our preganglionic axons are going to be short. So see how much shorter they are in comparison to our parasympathetic preganglionic neurons or axons. And our postganglionic axons are going to be very long here. The ganglia are going to be located close to the spinal cord. So if you look at this full body view, you could see these are the autonomic ganglia. Look how close they are to the spinal cord here. In fact, they are going to line up, and we're going to call this the sympathetic trunk. We will also have some other ganglia in which the sympathetic system will use, but we are going to discuss this within a different section. And our preganglionic axons, if you didn't notice already, are going to have many branches extending off. And I just wanted to include this slide so you guys can use a side-by-side comparison of the material we just discussed in order to see and highlight the differences between parasympathetic and sympathetic anatomical differences. Now let's take a look at the degree of response. Our parasympathetic activity is fairly localized. We have those long preganglionic axons with limited branches that are going to influence only one or few effectors at the same time. Our sympathetic activity is a bit different. It's going to facilitate mass activation. Our short preganglionic axons with many branches are going to simultaneously influence several effectors at one time. So exercise or fear can stimulate changes in many organ systems at once. And also, sympathetic stimulation is going to release our hormones within the adrenal medulla. This adrenal gland sits atop the kidney. The outer edge is called the cortex, and the inside is called the medulla. And in here we have epinephrine and norepinephrine that is going to be released and cause a mass activation, one of them being an influence on our blood vessels. And sometimes a single effector can be engaged. An example of this would be triggering pupil dilation within low light.